Welcome to our lesson on the periodic table. I'm Amabel.
And I'm Ahmed.
Also in our group is Sarvani, who, although is not present at this moment, is here in spirit.
Yeah.
So, going vertically down the periodic table are the groups, and going horizontally across the periodic table are the periods. Alkali metals, right here, are found in group 1A of the periodic table. These metals are soft and have low melting points and densities. All react violently with water, releasing hydrogen and forming hydroxides. They have an oxidation number and charge of +1, as well as one valence electron. In order of increasing atomic number, the alkali metals are lithium, sodium, potassium, rubidium, cesium, and francium.
All right. Well, found in group 2A are the alkaline earth metals. These elements are +2 oxidation number, charge, and 2 valence electrons. They are extremely reactive. Never found alone in nature. These elements are beryllium, magnesium, calcium, strontium, barium, and radium.
After the alkali and alkaline earth metals, in what some call the ditch, are the transition elements. These elements possess the properties of metals. They are very hard with high melting and boiling points. They have high electrical conductivity and are very malleable. The charge of these elements vary, which is why they can react with a variety of other elements.
Next comes the boron family. Boron is the only semi-metal in this group, and the rest of the elements, aluminum, gallium, indium, and thallium, are metals. These elements have 3 valence electrons and a charge of +3. After the boron family is the carbon family. These elements have 4 valence electrons and charge of +4.
The carbon family includes carbon, silicon, germanium, tin, and lead. Next is the nitrogen group. This group has 5 electrons in the outer level. These elements also form covalent compounds, usually with the oxidation numbers of +3 or +5. These elements include nitrogen, phosphorus, arsenic, antimony, and bismuth.
The next group is the oxygen group. The elements in this group are oxygen, sulfur, selenium, tellurium, and polonium. These elements have 6 valence electrons and a charge of -2. After the oxygen group comes the halogens. These elements are fluorine, chlorine, bromine, iodine, and astatine. Halogen means salt former, and compounds containing halogens are salts. They all have 7 electrons in their outer shell, giving them a charge of -1.
Finally, we have the noble gases. This group consists of helium, neon, argon, krypton, xenon, and radon. They have an oxidation number of 1, which prevents them from forming compounds. They are stable because they have the maximum number of valence electrons, 8, in their outermost shell. To find valence electrons, you count 1 through 7 for all the groups, skipping over the ditch, aka the transition elements. So you would go 1, 2, 3, 4, 5, 6, 7 valence electrons. So hydrogen would have 1 valence electron, while fluorine would have 7. To find charge, you count +1, +2, +3, +4, -3, -2, -1, again skipping over the ditch. So hydrogen would have a charge of +1, while fluorine would have a charge of -1.
Here are a couple of trends of the periodic table. Ionization energy is how much energy it takes to pull an electron from an element. Going across the periodic table, ionization energy increases. For with added protons, it becomes more difficult to pull electrons off of elements. Going down the periodic table, ionization energy decreases. For with added groups, electrons are further from the nucleus, and it is easier to pull an electron from the element.
Atomic radius is the distance from the nucleus to the outermost electron. Atomic radius decreases as you go across the periodic table, because negative electrons are more pulled to the nucleus with added positive protons. Atomic radius increases going down the periodic table, for there are more electrons blocking the outermost shell of the outermost electron from the nucleus, making the radius larger. The effect that causes negative electrons to repel other electrons, making the radius larger, is called shielding. Well, that's all. I hope you learned a lot about the periodic table.
Thanks and good night.